I'm here working with our Synergy S Max that you will see in a second. I've mounted a sample of quartz powder, and I just want to check what the diffraction pattern looks like with the full beam. And once I decrease the divergence of the beam, hopefully I'll get peaks with smaller full width at half maximum. And you will see the kind of sample that I've got. So the goniometer is moving up, and now on the far background here, you can see the sample of quartz powder I've got mounted. This is a regular single crystal loop. The width of the diameter of that loop right there is about 150 microns, and I've just filled it up with a bit of quartz powder.
And where's the divergence slit you're going to change?
So the divergence slit that will be moved is upstream here, right after the optics. So this divergence slit is built-in, computer controlled, so I can control the divergence of the beam without having to change the collimator over here. Now here you will see that data is being collected, and Crystallis Pro will automatically integrate the data and display an I versus 2 theta plot. And there it is.
But that was fast.
That was fast. So of course, with the full beam here, we've got rings that are fairly fat, and this is shown also on this diagram. So now I'm going to close the slit, and that's the nice thing about this device, is that I don't have to get up again and touch the hardware on the system at all. All I do from that X-ray button here at the top right, I right click and I say beam slit. And then I've got this sliding bar that allows me to move the slit onto the beam up to the divergence that I want. And it's done. Let me minimize that. I come back to the powder data collection module here. I leave everything the same. So we are almost there. I think we were rotating by 30 degrees along phi. Sorry, maybe I said omega before it was phi actually. So now let's compare the two spectra. So if you compare the two spectra, so let me make sure first that I am showing you the same resolution range. So you see all these numbers coincide. See how this low resolution double peak here, that between which the intensity was not coming back to background level, now it is underneath here with the cut divergence. This little shoulder here now becomes a completely separated peak. It's really easy. See, I haven't moved from this chair. Change the collimator. Two things there. Number one, you would put a smaller pinhole at the tip of the collimator, but you have no control over the size of the pinhole. It is what it is. So you may be cutting more than what you actually need to cut the divergence line. That's number one. And number two, you don't have to realign anything.